Hello, everybody, and welcome to your last week of third term and beginning of our second week of online schooling classwork. We're going to be talking about momentum and finishing up our energy unit before moving into next quarter. Uh, as I said, I have looked at your understanding energy worksheets and your check-in for your grades. So at this point, all the grades prior to today have been locked in. Okay, those are your locked in grades. There is one more grade to go in for third term. That is going to be the roller coaster design lab, which we'll be talking about in this video. So make sure you do that if you want to either pull up your grade or keep the grade you have. All right. So let's go over this week in our slides. Sorry for the scroll there. So our objective for today is I can model how potential and kinetic energy can change forms on the roller coaster design lab. Okay. And our activator is what is the law of conservation of energy? What does that say? So if we have two objects moving at a certain momentum or velocity and they smack into each other or collide, what happens to their energy? What do you guys think happens? All right. Pause the video now and think about it. 1, 2, 3. Did you get some tea? Did you get some soda? Did you, stretch a little bit? Awesome. Hopefully you answered that question. We're going to cover that in a moment. Just a reminder, understanding energy is due by tonight at midnight. The answer key will be posted tomorrow. Okay. So first off, after what is the law of conservation of energy? It's energy can change forms, but it cannot be created or destroyed. The total energy will be the same. So if we had those two balls we're talking about, if one was going 5 miles an hour to the right and the other was going 6 miles an hour to the left, when they both crash into each other, the higher number wins. So the 7 miles per hour is going to win versus a 6. So we're going to have 1 mile per hour left over. That means both of those balls are going to both go 1 mile an hour to the left. Okay. The energy wasn't destroyed, it was just changed. Okay. The total number of energy is still there. If that was not true, what could happen is if those two balls smacked into each other, if there was no conservation, the one ball would just stop in its tracks and just fall to the ground, while the other one would keep moving at basically at the same speed it was moving at. And we know that's not true. Okay, so energy is always the same. It just changes its form. And I hear some of you raising your hand going, Mr. Brando, what about nuclear reactions? That is an exception to the rule. You'll learn about that in high school for 8th grade physics. It's not as important. We follow the law of conservation of energy because for most things on Earth, this is what is important, even in the universe. The exception to the rule is very, 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 very rare. Okay. Now, so think about this. If we have a roller coaster, what happens to the energy of a roller coaster as it goes down the first hill, also known as the lift hill or launch hill, depending on what kind of roller coaster you have, and then up the second hill? Okay, so if we take a look at this picture here, let's look up here. So hopefully you can see my mouse. When you're at the very, very tippy top of this lift hill, usually your car is not moving. It usually stops. A lot of times it actually will stop there for a prolonged amount of time to basically enhance the fear factor of the roller coaster. Okay, so you're stopped up here. There's no kinetic energy. You are not moving. Okay, but if you look how high your cart is up from the ground, it has a lot of potential gravitational energy. How much gravity wants to pull that cart back to the ground? Okay, so up here it has its maximum potential energy. Let's label that as like 100. Okay. As gravity pulls down your cart towards this little dip here, you start exchanging this potential energy you had and transform it into kinetic. You start moving faster and faster and faster. So you're changing the potential into kinetic. You're moving faster and faster while your potential is getting lower and lower. That's an inverse relationship. And as we go down here, we now have the maximum amount of kinetic energy we're going to have in this little picture we have right down here, because you're moving the fastest you can be, right? But look how much lower you are. You've lost a proportional or a same amount of potential energy. So your potential energy is lower, your kinetic energy is faster. And as you go back up, you will start gaining potential and you'll be losing kinetic. So no matter what, the sum of your kinetic and potential energies would be equal to the 100 you started off with up here. Okay, so long-winded as I was, as the roller coaster goes down the first hill, it loses potential energy and gains kinetic, and then it gains potential energy and loses kinetic energy when it goes up the second hill. The energy stays the same. Okay. All right, so here's a better picture of this. So I can explain this. So here we are. Here's that 100 potential energy. Here's 0. See, as we go faster and faster, you're changing this at a 1-to-1 rate. So as you get to here, your kinetic energy is about 50. You're going about, let's say 50 meters per second. And your potential energy you can still go add on another 50 meters per second if you keep moving down. So if you look, you keep going further and further down. Once you get down to the dip, you're almost at ground level. So we'll pretend you are at ground level. So your potential energy is 0. You can't go any further down, but you are going the fastest you can. So you have 100% kinetic energy, 100 kinetic energy. As you go back up, you spend this kinetic energy to gain back some more of that potential energy. And it's always the same. 75 plus 25 is 100. Right? 50 plus 50 is 100. And that 100 comes from here. We didn't lose any energy. Now, some of you are probably scratching your heads going, but roller coasters stop, or I've been on a roller coaster and it slows down, or it's if I was on a roller coaster or a skateboard, eventually I come to a stop, Mr. Brent. If I go to the top of a hill, I don't keep going forever. That's true. Okay. If you think about it, right here, we have this wood here that this coaster's on. As those wheels roll across it, there's something called friction that happens, which causes heat. There's also air resistance. The molecules in the air push against the cart. All of those functions are transferring this a little bit of this energy, a little bit at a time, into a different form. Instead of kinetic, it might go into heat. Okay. So it siphons that off. So eventually, over time in the real world, your car will come to a stop. That's high school physics. For 8th grade physics, all you got to worry about is that it's a perfect world. We don't have friction and we don't have air resistance. So if you have 100% potential energy at the top of the hill, when you get to the bottom of the hill, you'll have 100 kinetic energy. And anywhere in between, if you add the potential and kinetic energy together, you're going to have the same number as you started with, in this case, 100. I hope that makes sense. If you don't understand, feel free to email me. I will try to help you the best I can. Okay. Now, as I mentioned before, it's an inverse relationship, right? So as kinetic goes up, as the faster you go, you're going to lose potential. As your potential goes up, you're going to lose kinetic. They are inverse relationship. They are in a negative relationship. They are opposing one another. Okay. Now, if we go down here, so here's an example of a rocket. Okay, so we let the rocket off and it goes up into space, and not space. Let's say atmosphere. So it goes up into the atmosphere, and it makes this arc, this parabola or arc, and basically once it gets up to here, its engine cuts out. So if you've ever thrown a baseball straight up, you might have noticed this. Once it gets to the top of as fast as much energy put in it, it comes to a stop basically. It just stops where it is. At that point, it no longer has any movement, or as we know, kinetic means movement. It has no more kinetic energy. It has 0 kinetic energy. But if it looks down like Wile E. Coyote, it has a long way to fall to the ground, and that is called our potential energy. It has a potential to fall or gain energy from the Earth's gravitational force. So what happens is that force begins to pull on it, and it begins to move the rocket again. It starts picking up speed, picking up speed, picking up speed. But it exchanges its height for that speed. So its potential energy is changing into kinetic energy. So as we get to the middle of that parabola, about half of it's turned into kinetic, half of it's in the potential because it's lost half its height, but it's going basically double its speed. Now, if we think about it, once we get to the logical conclusion, we get to the very, very end here, right before it hits the ground, before it touches the ground, right? It has nowhere else to fall, so it can't go any further. It can't go through the Earth. It lost all its potential. It cannot go any further, so it has no more potential energy, but it has all of its kinetic energy. So it has the greatest amount. It's going as fast as it possibly can. Okay. So if you're looking at a parabola, remember the top will have the most potential, but least kinetic. Bottom will have the most kinetic, but least potential. All right. So this roller coaster online activity. All right, let's talk about this. This is the last assignment. It's worth 20 points. Please do it. It's worth your test points. It's worth the all task points. So it's actually something worthwhile to do. Okay. Now, when you look at Google Classroom, you're going to see two different options. This is the main option. This is what I prefer you to do. All it is basically one of our little web quests, and it's going to be a lab. If you click on here, you will see this little the simulation we did before. We've used it before. It seems familiar. You're going to use that to answer this question here. And then you're going to click on this one here. It's going to take you to this website. And there's a little interactive, and you can draw how you want your roller coaster to look. Okay. You're going to use that to answer these two. There is a little video to watch, all on roller coasters. It's actually really, really fun. It's good to play around with, and it won't take that much time. It will feel like, but don't put it off until the last minute because again, third term ends on Friday. Anything beyond that, I can't take, and this is worth all task points. So make sure you get it to me by Friday by 4 p.m. If we look over here, you'll also see something called Energy Skate Park. So if you don't care about roller coasters or your Flash does not work, if you can't get Flash to run or the simulations run, here is your alternate assignment. You can choose to do this if you'd like. It's about a skateboarder. It's provided by the county, so it should work on your Chromebooks. So if you want to learn about Tony Hawk and that kind of fun stuff, go ahead and design a skate park. Follow these links and you fill these blanks. Make sure you pick one or the other. You do not have to do both. If you want to do both, am I going to stop you? Heck no, of course, have fun, do both if you want to. But it's a lot of work, and we all have something going on during these weeks now, and I don't want to put too much on you, so pick one or the other and turn that in, okay? If you have any questions on Wednesday, as I said before, I'm going to try to do a Zoom meeting. If that doesn't work, I'll post something about it. If not, we'll definitely have email and the discussion board, so if you have any questions about this, that would be helpful. There is also going to be a discussion question that will help you learn about momentum a little bit, which will help you answer these. Make sure you look at that as well. And if I don't see you Wednesday because of Zoom being weird or something, I will definitely see you next week. I hope you all are having a lovely had a lovely break and you're still doing okay and you're safe. And if you want to talk to me or reach out to me, that's always okay. Remember, there's emails, and I hope this video was informative and helpful, and you guys are doing okay.